Mercury is in trouble. Scientists have discovered that Mercury is dragging behind it a gigantic tail stretching nearly 3.5 million kilometers through space. This phenomenon is extremely rare. Nothing like it exists on any other planet in the solar system. So what exactly is happening to Mercury? Has it crossed the sun's Roche limit and begun to break apart? After all, in our solar system, only comets are known for their beautiful glowing tails. But Mercury is not a comet, it's a planet. So why does it orbit the sun with a tail millions of kilometers long? And since Mercury is so close to the sun, why hasn't it been swallowed by the sun's immense gravity? Today, we're going deep into Mercury to uncover the mysteries hidden on the most difficult planet in the solar system to explore. For a long time, many people mistakenly believed Mercury was covered with liquid water, but in reality, Mercury is a lifeless, barren world with no liquid water on its surface at all. In fact, Mercury is the smallest planet in the solar system, and its surface is covered with countless impact craters. Because Mercury lies so close to the sun's enormous gravity pulls huge numbers of asteroids and comets inward toward it. As a result, Mercury has been heavily bombarded for billions of years, leaving its surface scarred and ancient. And because of this, Mercury is destined to suffer constant impacts from countless small celestial bodies. Many people may find it strange. The sun's mass is more than 6 million times greater than Mercury's. Not only is Mercury the smallest planet in the solar system, but it is also the fastest orbiting planet, racing around the sun at an incredible speed of 48 kilometers per second. It never slows down, maintaining this speed as it has circled the sun for billions of years. That's exactly why exploring this planet has been incredibly difficult for humanity. In fact, more than 40 years ago, scientists studying Mercury discovered a puzzling phenomenon using advanced spectroscopic analysis technology. They detected faint yellow light coming from sodium atoms in Mercury's atmosphere. This discovery deeply confused researchers because such a phenomenon is extremely rare on other planets in the solar system. At the time, some bold scientists proposed a fascinating theory. These sodium atoms might actually be forming a mysterious comet-like tail around Mercury. However, due to the lack of direct and clear observational evidence, the idea was pushed aside and left unanswered for years. Everything changed in 2001 when German astronomers Schmidt and Walter were conducting observations on La Palma Island in Spain. Using high-precision telescopes and specially designed filters, the astronomers captured an unbelievable sight in long-exposure photographs. This image became the first real evidence of Mercury's strange phenomenon. In the photo, a faint glowing tail could be seen stretching deep into space. At the time, scientists estimated that Mercury's tail might extend as far as 2.4 million kilometers, more than 490 times the diameter of the planet itself. At the same time, researchers uncovered another astonishing fact. Mercury is actually a metallic world. This groundbreaking discovery shocked the scientific community and completely changed humanity's understanding of the planet. Although Mercury's diameter is only about 4,880 kilometers, nearly 70% of the planet is made of metal, making it a true giant iron-rich world. If calculated based on humanity's current rate of metal consumption, the amount of metal on Mercury could theoretically supply human civilization for at least 100 billion years. The reason Mercury contains such an enormous amount of metal is mainly because it formed in the inner region of the solar system, where intense heat and the sun's powerful magnetic field allowed heavy metallic elements to gather more easily during the early stages of planetary formation. After all, Mercury is the closest planet to the sun, constantly enduring violent solar winds and extreme heat. This is why the planet experiences scorching temperatures during the day and freezing temperatures at night. The enormous temperature difference makes it almost impossible for life to exist there. Even though Mercury is a metal-rich planet, humanity has no realistic way to mine and transport those metals back to Earth. At their closest, Earth and Mercury are still about 77 million kilometers apart. And when the two planets are on opposite sides of the sun, the distance between them can reach an incredible 220 million kilometers. But this raises an even bigger mystery. Why would a metallic planet have such a massive tail? To uncover the truth, scientists developed a special space probe called MESSENGER. The spacecraft was successfully launched on August 3, 2004. After nearly 7 years of traveling through space, Messenger finally entered Mercury's orbit in March 2011. One of its main missions was to determine exactly how Mercury's strange tail was formed. During multiple close passes around the planet, the probe confirmed that Mercury's tail was made of sodium atoms. Scientists also discovered that the tail was far longer than the original estimate of 2.4 million kilometers. Instead, the tail was found to stretch an astonishing 3.5 million kilometers, equal to about 9 times the distance between Earth and the Moon. But why are these sodium atoms escaping from Mercury's surface and forming such a spectacular tail? The answer is closely connected to the immense power of the Sun. In the solar system, the Sun is the absolute central body. Not only does it provide light and heat to the planets, but it also constantly releases solar wind, a stream of high-speed plasma made of charged particles. When these powerful solar winds crash into Mercury's surface like raging waves, it's almost like a violent atomic bombardment. The Sun's energetic particles strike the surface and blast sodium atoms away from the planet. Once these atoms escape Mercury's weak gravity, they are pushed into space, forming the enormous glowing tail trailing behind the planet. The entire phenomenon happens for one main reason. Mercury is simply too close to the Sun. Although the Sun's radiation pressure may seem weak, over long periods of time it continuously pushes the sodium atoms farther away, creating the giant tail we observe today. So Mercury has not crossed the Sun's Roche limit, nor is it being torn apart. Instead, its strange tail is the result of a delicate interaction between Mercury's surface, the solar wind, and the Sun's relentless radiation. After all, Mercury's orbital radius is far greater than its Roche limit, and its orbital speed is incredibly fast, reaching nearly 48 kilometers per second. This tremendous speed allows Mercury to maintain a stable orbit around the Sun, preventing it from being pulled inside the Roche limit or torn apart by the Sun's gravity. Even though Mercury's sodium tail stretches an incredible 3.5 million kilometers, seeing it with the naked eye is almost impossible. The tail is extremely faint and hidden within the dark background of space. To observe this mysterious phenomenon, astronomers must use special sodium filters. These filters act like magical keys, blocking out other wavelengths of light and allowing only the unique 589 nanometer wavelength emitted by sodium atoms to pass through. With these filters, telescopes can finally capture Mercury's long, glowing tail. The discovery of Mercury's sodium tail is far more than just a fascinating story about the solar system's smallest planet. It has opened an entirely new window into the deeper mysteries of space. By studying this strange tail, scientists can better understand the physical and chemical properties of Mercury's surface and atmosphere, as well as the complex interactions between Mercury, the Sun, and the solar wind. After all, Mercury has been exposed to the relentless bombardment of solar wind for billions of years. Even after billions of years, Mercury continues to orbit the Sun steadily at an astonishing speed of 48 kilometers per second without being swallowed by the Sun's immense gravity. In the end, the explanation can be summed up in one word: speed. Mercury moves so incredibly fast that even today, only 2 spacecraft missions have successfully traveled there. That's why scientists often call Mercury the most difficult planet in the solar system to explore. If you ever wanted to travel there aboard a spacecraft, the safest option would probably be landing on Mercury's dark side during nighttime. That's because nighttime temperatures on Mercury can plunge to an icy minus 173 degrees Celsius, while daytime temperatures can soar to a blistering 427 degrees Celsius. And surprisingly, extreme cold is actually easier for humans and spacecraft to handle than extreme heat. That's why a nighttime landing would be far more practical. But why does Mercury experience such enormous temperature differences? The answer is simple. Mercury has almost no atmosphere. Without a thick atmosphere to distribute and trap heat, temperatures across the planet become wildly uneven. As a result, Mercury experiences greater surface temperature fluctuations than any other planet in the solar system. After all, durable spacesuits and insulation systems can temporarily protect astronauts from freezing temperatures, but surviving Mercury's intense daytime heat would be far more challenging. After stepping out of the spacecraft, you could try taking a short walk across Mercury's dark side, exploring its enormous impact craters and experiencing what it feels like to stand alone on the surface of the closest planet to the Sun. But you definitely wouldn't want to stay there for too long. On Mercury, Both daytime and nighttime each last about 88 Earth days. Once the sun rises, the planet's surface begins heating under relentless solar radiation. In those extreme conditions, a human exposed for too long would quickly be overwhelmed by the intense heat, with almost no chance of survival. So now you can probably understand why Mercury is considered one of the most difficult worlds in the entire solar system to explore.